Yes, ma'am.
Okay. So now those of you who are having doubts regarding your assignments, you may ask me your doubts right now, okay? But before I clear your doubts, tell me, was it today or Saturday last day to submit your lab work and your assignment? Prakash, is it today? Was it today or Saturday?
And today?
Today. It's today, right?
Yes, ma'am.
Okay. Okay, so some of you are having some doubts. Okay, Rijwana, thank you. So if you still are not clear, then you may ask me now. But because you were asking me yesterday, that means there was no use of giving you one extra week to complete your incomplete work. The last date of last week, you came up with the प्रॉब्लम कि मैम समझ में नहीं आया कि क्या करना चाहिए था, क्या करना चाहिए था, कैसा लिखना चाहिए था. So whatever you asked me कि मैम कैसा लिखना चाहिए, मैं I cleared everything. ओके. तो क्योंकि आपने लास्ट टाइम भी एक दिन पहले ही पूछा था, सो आई एक्सप्लेन्ड एवरीथिंग, हाउ व्हाट शुड बी द कंटेंट ऑफ योर असाइनमेंट, हाउ शुड यू राइट योर असाइनमेंट. And then because that was your first time dealing with me, so I told you, okay, no, not an issue. After clearing all of your doubts, how you should be writing your assignment last week, after clearing all of your doubts, I gave you one extra week. ओके, ठीक है, क्योंकि आपको समझ में नहीं आया कैसे असाइनमेंट लिखना चाहिए था, आपने पूछा, वो सोच के मैंने आपको एक एक्स्ट्रा वीक पूरा दिया, जिसमें आज आपको सबमिट करना था. उसमें से फिर से आपने कल मुझे, क्योंकि आज लास्ट डेट है, फिर से कल आप मुझे पूछ रहे हो कि मैम असाइनमेंट कैसे करना है. आपको ये जोक जैसा नहीं लग रहा? डोंट यू थिंक यू आर लाइक, is it some kind of joke? Your master students, you are repeating that same stupid mistake this week as well. If you were still having confusion on writing how your assignment should be, that question should have come right after the day when I cleared all your doubts and gave you one extra week. I think last time Thursday you were supposed to submit. Wednesday you came up and you asked me the same question कि मैम कैसे करना है, समझ में नहीं आया. I scolded you कि आज थोड़ी ना पूछने का दिन है, कल सबमिशन है. Then I spared you with one more week by clearing all your doubts regarding your assignment. And then again you're doing the same thing. आपका 1 week का जो एक्स्ट्रा टाइम था वो खत्म कर लिया, आज सबमिट करना है. एंड यस्टरडे यू आर आस्किंग मी कि द सेम क्वेश्चन, यू आर कमिंग अप विद द सेम क्वेश्चन कि कैसे क्या लिखना है असाइनमेंट में. Then what is the use of giving, what was the use of giving you one extra week? I don't know. And when I gave you assignment, I had told you that in the Google class, you join Google class, then you'll have to submit your assignment. Last night I created one submission line, assignment submission and lab submission line in your Google class because today was your last date. तो मैंने कल रात बैठ के वो सबमिशन के लिए I made a submission link in the Google Classroom. And many of you like Shivangi, Bhomik, Shriram, Subhash, you have submitted, and Subhash, Shriram, नहीं Shriram नहीं, एक और था, Ram Ray. You have submitted, and also Rashmi, you have submitted your assignment or your lab work in my email. I told you not to submit any of your assignments and lab work, not to write me an email for that. I asked you to submit it in the Google Classroom, and because today is your last date, yes, last night I have created assignment and lab work submission place in your classroom. So why did you write me an email when a clear instruction was given to you? आप लोगों को समझ में नहीं आता है, आप लोग सुनते नहीं हो कि क्या इंस्ट्रक्शन दिया जा रहा है. Or are you forgetting you are a PG students and not first year bachelor student? Even second year, third year bachelor student would be doing better than you guys. राम राम रे ने हाँ, राम रे आप उसके लिए बोल रहे हो या सबके लिए बोल रहे हो? अच्छा, आपके लिए बोल रहे हो तो ठीक है. हाँ, आपका थोड़ा मिस्टेक हो गया, ये आपका सेशनल का ही था और 21 जून का है. बट आई एम नॉट
मैम
टॉकिंग अबाउट.
मेरा भी वही गलती हुआ था।
आप कौन है? रश्मि.
यस मैम।
रश्मि, हाँ सॉरी, रश्मि का भी. अच्छा, रश्मि का भी, हाँ सेशनल का ही है. अपार्ट फ्रॉम रश्मि एंड राम का, other students like Shivangi, she has submitted OS assignment and laboratory assignment in my email. Bhomik, you have submitted your assignment in my email. श्री, सॉरी ये दूसरा है, मनोज, ये वाइवा का है. सुभाष, you have submitted your lab work in my email. Okay, so I think I've made myself clear. You can email me your assignments or laboratory work. However, you're supposed to make the submission in your Google Classroom. And again, in Google Classroom, two separate two separate directories have been created. One for lab, where it's clearly written lab, laboratory assignment. Another is just your theory assignment. In your theory assignment, you'll submit your theory related assignment that has been given to you, assignment 1. And your laboratory assignment, you'll submit your programs. It's not rocket science, it's simple thing related to your Google apps. And you are PG students in a central university, so behave like one. Stop behaving like school. Nowadays, even school going kids are more familiar with such platforms. And don't repeat this mistake of asking Mickey ma'am what should be in the assignment again in future, one day before the submission. If you'll ask me the same day, if you'll ask me the same question right after 2, 3, 4 days of the 4 days after I've given you the problem, I'll answer, I'll acknowledge, I'll happily repeat it thousand number of times. Like last time, one day before you, when you said मैम क्या लिखना है, क्योंकि वो पहली बार था आपका मेरे लिए, मेरे as my student, that was your first time. So I cleared all your doubts कि मैम ऐसे लिखना है केस में, मैंने बता भी दिया इस तरीके से उस तरीके से. Then I made myself clear. I asked you several times, is it clear? Do you still have any more doubts? When I asked you, do you have more doubts apart from Pravesh? And there is one more guy whose name starts from S. I think Subhash. These are the only few people who writes the samjha ya nahi samjha. If they have doubt, they ask your doubts. And if it's clear, they write clear. Other people, they are like clear, 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 clear. But at the time of submission, one day before, if you write me कि मैम समझ में नहीं आया, फिर से बता दो, that 2 second time in sequence. Don't do that. मैंने आज असाइनमेंट दिया, मैं मिनिमम भी 1 हफ्ते का गैप देती हूँ असाइनमेंट सबमिशन के लिए. If I've given you 7 days time, that doesn't mean on the 6th day you'll come to me asking me कि मैम क्या लिखना है. If you want to ask me क्या लिखना है, that should be first day, second day, third day, fourth day. Okay, with some chances on 5th day, okay, but not on 6th day, because 7th day you are supposed to make the submission. So whatever queries you'll have that you'll post me on 6th day, I will respond very rudely. Do it, or let's see, like that. क्योंकि आज रात को 12 बजे सबमिट करना है, अब मुझे 7 बजे सुबह लिख रहे हो कि क्या लिखना है. That means you're not working on your assignment. Assignment carries marks. That means you need to put your hard work. And it's not that if you make your submission and I assign 10 marks, then you're sure that you'll get 7, 8, 9. No. In my assignment, students gets 1, 2, 3, 4 because you copy paste it from some links and some Wikipedia page. You don't put any hard work. You don't prepare any comparative study of your own, or you don't put any of your understanding. कि आपने उतना पढ़ने के लिखने के बाद आपका खुद का क्या ऑब्जर्वेशन था. यू डोंट नीड एनीथिंग लाइक दैट. यू जस्ट गेट इट फ्रॉम द इंटरनेट, गेट इट पेस्टेड. That was the reason I did not clear your doubts related to your assignment yesterday. At first I realized कि मैंने सैटरडे को बोला था. Then I said okay कल. Then किसी ने लिखा कि मैम हमें कल सबमिट करना है, कुछ मुझे पर्सनल मैसेज था या ग्रुप में ही था, आप बता दो. देन आई रियलाइज कि कल सबमिट करना है, तो आज फिर से पूछ रही हूँ. दैट मीन्स यू आर रिपीटिंग द सेम स्टोरी ऑफ 1 week बिफोर. तो 1 week बिफोर मुझसे टाइम क्यों दिया 1 हफ्ते का? फिर don't do that. Your PG students act like one. Don't behave like kiddish. All of you are above 20, so that means you are a mature human being. Act like one. And don't forget, you are in a central university. You are not in some private university, or you're not first year bachelor students. Even second year and third year bachelor students are expected to behave like the university going kids. आप कॉलेज में भी नहीं हो, आप एक यूनिवर्सिटी में हो, वो भी सेंट्रल यूनिवर्सिटी में हो, मास्टर्स कर रहे हो, 20+ हो, और आपका एडमिशन ऐसे ही नहीं मिला है, आपके क्रेडिबिलिटी पे मिला है. तो डोंट मेक योरसेल्फ लाफ एट योर ओन क्रेडिबिलिटी. जब मैं पढ़ा रही हूँ तो होती हूँ, I ask you several times, is it clear? Is it clear? That time also you can ask me if you have any doubts. When I gave you assignment, when I give you the problem of assignment, this is what you have to do. Okay, fine, you didn't understood in first go, but you hesitant to ask. Okay. When at the time of submission you asked me, some of your friends asked me, ma'am, समझ में नहीं आया, क्या करना है? Then I explained. If you are not clear at that time, you could have asked me that same day or maybe probably next day. Every lecture, before I start the lecture, I ask you any doubt from previous lecture, any doubt from last lecture. At that time तो नहीं मैम, सब क्लियर है. जब आया सबमिशन का डेट, एग्जाम का डेट, तो फिर ये नहीं, वो नहीं, ऐसे नहीं, वैसे नहीं. I understand it's online class, you're having difficulties, but that does not mean we are at ease. If I could see you in the classroom, I can make it from your faces कि हाँ समझ में आया या नहीं. So looking at you, I will come to know if I have to repeat or not. But here I cannot see you. I don't even know if you have turned on your computer and left for some other work. I don't know if you are preparing your notes or not. And also I don't want to impose you कि notes बनाओ, submit करो, because it's COVID. सबके साथ कुछ stress हो रहा होगा. I don't know what अभी कौन से phase में चल रहे हो आप, what is going around your environment. It may be some unfavorable things are going around you. So if I put pressure, you may not be able to handle it. So if somebody is giving you some chances, then don't take leverage of it. Try to act, I repeat again, try to act like a mature human being. क्या फायदा हुआ 1 week का? I was expecting कि ठीक है, लास्ट टाइम तो मैंने दे दिया. Now even they might be happy कि 1 extra week मिल गया, अच्छे से करके सबमिट करेंगे. I have no more. I don't need to please you guys, but still I'm putting you guys in the front row. I'm trying to make कि हाँ हर टॉपिक को लेके, असाइनमेंट को लेके, लैब को लेके, I'm keeping everything open कि ठीक है, query है post me, query है post me. I'm making myself available in WhatsApp. I'm trying to take real-time classes so that if you have any doubt, you can make your doubts clear. I'm trying to show you how questions are asked in competitive exams, so that if you try to prepare for any in the future, you'll at least have अच्छा यहाँ से इस तरीके से आता था. Once one professor talked about it. One or two of you are really brilliant. Okay. But you need to act responsible, man. You cannot be reckless all the time. If you are given some job, you are expected to perform. If I don't expect excellence from you, at least I expect average from you. I'm trying to teach discipline. I'm trying to give you time. I'm trying to be understanding. I'm trying to make topics clear. But it seems that just because I'm being nice, you're taking advantage of it. The classes started 20 minutes before, and there are students joining right now. Wherein I have made this very clear in the beginning that after 5 minutes, I'll not allow permission to join the class. Somebody joins the class 40 minutes after the class is started. Remember, though it's online, but class is going on. If you think it's tough for you, it's equally tough for us. If it's a classroom, then I can take break, but here I have to continuously talk for 1 or 2 hours. If you don't know the pain of doing that, I will give you topic, prepare presentation and speak for 1 hour. Trust me, you cannot even, when you will prepare your topic, whatever you prepare, you'll finish it in 10 minutes. Then what will you talk for the rest of 50 minutes? Then you will understand the pain. If I'll give you topic, now it will be very easy for me. You have to study, you will cover the syllabus. But I would like to believe that's my job to teach you, and being student, it's your job to question me. So perform your part and I'll perform mine. Don't worry about syllabus. I'm an experienced teacher. ऐसा नहीं है कि ये मेरा first year of my job that I don't know how and what things goes, how things goes. I know my subjects. कौन से subject में I cannot skip classes, कौन से subject में I can cover syllabus by taking how many classes. If this subject was cryptography and network security, mobile and wireless network, graph theory, mathematics, then I have to take all the classes, maybe extra classes. But the syllabus of this one is not huge. So I'm an experienced teacher. I know कि कौन से subject के मुझे कितना time देना पड़ेगा. Don't question my credibility, nor question yourself. I'm not asking you to question yourself. I'm just asking you to behave like a postgraduate student. Don't compare yourself with others. Compare yourself with your last performance. If you're consistent, then be disappointed. If you have improved, be happy. If you have decreased, then improve yourself. Don't feel demotivated. If your friend is scoring more, you are scoring less, then that doesn't mean you're not good. But please don't do that because you are in first year, you have 2 more years to go. Don't do this to me. If I'm giving you extra time, then again in the last day or one day before the submission, don't come and asking me कि मैम कैसे हमें समझ में नहीं आया. That means you're just doing time pass. And if you are to do time pass, then submit anything that you want to. Don't ask extra time from me. Okay, anyways, let's start with the lecture. Again, before starting the lecture, I'll repeat few things. That is, in the Google Classroom, I've seen, I think the strength of your classroom is 17, out of which 2 students have dropped out. So the strength is 15. Out of 15 in the Google Classroom, only 8 of you have joined. That means 7 of you have not joined in the Google Classroom so far. So join the Google Classroom. In the Google Classroom, 2 assignment places, directories have been created. One for theory, other for laboratory work. Okay. So submit your assignment related to your OS theory in the assignment theory directory, and submit your laboratory assignment in the laboratory assignment directory. जो जिसका है laboratory में theory, don't submit laboratory work in theory directory and theory work in laboratory directory, nor email me. Upload it on that day. If you are late, then automatically it will be marked late in that portal. You'll come to know if you have submitted on time or late. Okay, so you'll come to know by yourself. So those of you who have not joined, join in the classroom. Prakash, you also have to submit your assignment. Okay, so in the Google Classroom code has already been shared. Prakash, also tell your fellow friends like Jayanti, Hisse and all, because this assignment will be given some portion of your sessional marks. So tell your fellow friends to submit this assignment on time, because they'll have to give the sessional 3, and sessional 3 will be conducted for maybe 10, 15 or 20 marks depending upon how many assignments I give. Okay, so that's it. So now before I start with new topic, tell me if is there any query from the lectures that have been covered so far. Before I move on to new topic, is there anything that you want me to explain? Is my screen visible?
Yes, ma'am.
Okay, so let's start the lecture. So whatever I've told, just forget about it and concentrate on what we are going to study today. Okay, so today I'm going to cover 3 or 4 topic, okay, or probably 4 or 5 topic. And the first few topic or the definition aspect of the topic that we are going to explain are simple, okay. Then we are going to see some of the numericals if time permits. So that first topic that we are going to discuss in today's lecture is swapping. This is one small and crisp topic. You need to be clear about its definition because various smaller definition exist in operating system based upon which various questions are asked in exams. Okay, and you get students often get confused with the definition of such small topic like dispatch, context switching, swapping, uh, PCB, various components of your PCB, okay, like data, control, stack, etc., etc. They ask various questions from smaller topic, okay, and you often just remember the definition for university exam purpose. And when asked in competitive exam with some fancy statements, students often gets confused, okay. So don't get confused, these are smaller simple topic. You just need to remember it कि अच्छा ये context switching is when we switch from one process to another process within the main memory or within the ready queue, okay. Dispatch is when we dispatch or when we move or swap processes from your processor, okay, remember, from your CPU to your secondary memory, for example storage, disk and all, okay. So when we skip swapping process between your secondary memory and your processor, that is when we call it as dispatching, okay. Swapping is the process. Swapping is the process of taking out your processor from your CPU and putting it back to your CPU, okay. From where? From the secondary memory, okay. This is the process, okay. So let me explain with the diagram. So this is my main memory. We know that a portion of your main memory is occupied by the kernel. So here I have the kernel. So now we call this space. Okay, so this is occupied. For example, if your mobile phones or your laptops RAM is 8 GB, then the OS that you have installed in any of these devices occupies a portion of your RAM. Okay, for example, if it's 8 GB of your RAM and your kernel of operating system occupies 200 MB, then the remaining memory is your if 8 GB, then 7 GB. How much of the RAM? If this is like 1024 MB, so that is your 1 GB. So from 8 GB, 1 GB is taken by the RAM and other related drivers like your mouse, etc., etc. So user space, okay. So the remaining main memory that a user can use is called as your user space. That means this is the space the process that we will be initiating will be able to use it, okay. So we call this as your user space. Okay, so now this is your main memory, and then what I'm explaining to you is swapping. Okay, so now this is my disk. Okay, so for this different articles that you might be referring, different online sites or books or journals that you are referring, they use different term for this disk. Some call it as secondary memory, some call it as disks, some call it as a backing store, okay, and some book call it as backing storage. So all of these fancy words means the same thing. It is your hard disk in your laptop. For example, the secondary memory where you create different drives like C, D, E, F, etc., etc. Okay, so whatever programs that you have, whatever files you have, that is actually stored in your secondary memory but not in your RAM. This is the basic of computer science that you already know about. Okay, so let us say this is the process we have, okay, P1, and this is the process P2 in my backing store or disk, whatever you would like to call it. So let me write down disk or backing store for now, so that you become familiar with the word backing store or secondary memory. In the future, I'll not be writing the same word again and again. Okay, secondary memory. Okay, so now when we have to perform, we know that depending upon the algorithms that we have studied so far, these CPU scheduling algorithms, first come first serve, your shortest job first SJF, shortest remaining time first SRTF, round robin, or your priority scheduling algorithm. Other than this, also there are hundreds of algorithms in the market. So when the one processor, okay, so one processor has to be brought into main memory, and one processor is done using the main memory, it is swapped out and stored in the disk. Okay, so the operation here, it is called as swapped out. So what is swap out? Swap out is a process, sorry, it is a phenomena where we take out one process from the main memory. Okay, we take out the process from the main memory, put it back in the backing store, and the space that has been created by the process in the user space. For example, if P1 was taking this much of the space, okay, that means now this space has become vacant, and when we bring some other process that is ready to be executed, bring it back to the main memory, then we call it as swap in. We call it as swap in. Swap in happens in the main memory. Swap out is taking out of the process from the main memory and putting it back into the backing store. That means that process is now terminated. But in many of the situation, when that process is not used for long period of time, but the process is not yet dead. Okay, for example, if I'll open this one folder from my computer right now, okay, and I'm taking 2 hours of the class, that means that process was created, that means that process is there in my main memory. For example, if I'll open calculator right now, okay, that calculator, that means goes to the main memory, and then I'm not using it for 2 hours because I'm busy with the class. So temporarily, what my operating system will do is, because I am not using it, so temporarily it will take out that from the main memory, put it back in the secondary store. The moment I'll go back to the calculator, okay, so it comes back to the main memory. Okay, so that time also we perform swapping. So in any ways, at any moment, if we are taking out a process and putting it back to the main memory, then it is called as your swapping. Okay, so here two memory are involved. One is your main memory, another is your secondary memory. Okay, so now this is swapping. Let me explain context switching. What context switching is, when we switch from one process to another process, but within the main memory. It is your context switching. What was your dispatch? Dispatch is when we take out process. Okay, so when we take out process from the CPU, this is your main memory, this is your backing store. But now if I have your CPU, so now if I have process in your CPU and I'm taking it out from the CPU and putting it back to the backing store, and from the backing store to the CPU, then we call it as dispatch. Okay, so these are the three concepts that you must know about your operating system, where we are handling with different processes. Okay, so is it clear? If it's clear, write in the chat box yes. If not, write down no, so that I can move to the next topic.
Clear, man.
Okay, thank you everyone. So now, often books refer the or use the term swap out or swap in. But again, some of the author would like to use some other term. Okay, but that means the same thing. So let me write that word for you, or that phrase for you. Some books, they use the word, or some competitive exams as well, roll out. Okay, roll out or roll in. So your roll out means swap out and your roll in means swap in. Both of the words means the same thing. Okay. So is roll out and roll in clear?
Yes, ma'am.
Okay. Okay. So now from here, okay, so it has this diagram or this concept has something to do with the binding that we studied in the last lecture. Binding. Can anyone tell me anything, any concept or any idea that has popped out in your head right now? कि अच्छा binding और इसका क्या लेना देना हो सकता है? Anything that's coming to your head right now, or in any way are you able to link the concept of address binding that we studied in the last lecture with the swapping that we are studying in the current lecture, today's lecture? Any word, any phrase? Either you can unmute yourself or write it in the chat box. Any random thoughts or anything that is coming to your head? If yes, write it down. If no, then write no. Achha, no, ma'am. Okay. So, okay, then listen carefully, okay? But then after I explained this idea, this was, I think, twice asked in two different competitive exams. So, listen to it carefully. After listening to it, if you think you have not understood the concept of address binding, ask me again. Okay, मैं explain करूँगी ये. While explaining this, I'll directly use the term load time, compile time, and your execution time. I have explained all these three types of address binding in yesterday's lecture. And if you think, after explaining this in context to your swapping, if you feel I should repeat address binding without hesitation, tell me. Okay. So now, while I was explaining you swapping, this was my main memory. And main memory, here I've got my secondary storage. Okay, now I'm going to write down only disk. So now I'm performing swap out and I'm performing swap in. So in a portion of main memory, I've got my kernel. Okay, so in the disk, I might have multiple processor. So let me write down process 1 and process P2. So now what I'm going to tell you, listen to it carefully. Normally, a process that is swapped out will be swapped back to the main memory into that same memory location, okay, that it had occupied earlier. Let us say process P1 needed a total time of 20 minutes. At 10 minutes of time, process P1 for some reason, okay, for some reason it was swapped out of the main memory and sent back to the backing store. Meantime, process P2 was brought into main memory. So after a certain time, because it still had 10 minutes of burst time remaining to complete its task, it needed 10 more CPU burst time. So it has to be brought back into main memory for it to run into the processor for 10 more minutes. So normally in such cases, the same memory address where it resided in the main memory earlier, it will get that same address back. Okay, this will happen if binding is done at assembly time or load time. Assembly time means compile time. Assembly time. Okay, your compile time binding is also called as your assembly time binding. Some books refer the term compile time, some books use the term assembly time. So now your process P1, if it was swapped out, and it has to be now if swapped back into your main memory, then it will be given that same address space of your main memory, if address binding is done at compile time or your load time. But now if execution time binding is being done, a process can be swapped in or swapped out into any different address space. Okay, लेकिन अगर हमने if we did execution time binding, if we are doing execution time address binding, then after the process was swapped out in round 1, when it has to be swapped in into round 2, it it may be given, let us say this is the address space, it initially was 10 to 20 address space. So now at the time of swapped in, it may be given, let us say 30 to 40 of address space if it is execution time binding. But if it is your compile time and load time binding, then the initial address space of 10 to 20, it has to be given that same address space when it is brought back into your main memory again in the future. Okay, so is it clear now? How is your swapping related to your address binding? Is it clear or are there any doubts?
Not clear, ma'am.
Okay, others? Prakash, Rijwana, Ram, Bhomik. Bhomik. Little confusion, ma'am. Shivam, clear. Okay. Rijwana, clear. Okay, Bhomik, कहाँ पे confusion है? Which part should I repeat? Bhomik, आप कल के क्लास में present था? Were you present in yesterday's lecture? भौमिक नहीं, भौमिक ने बोला है, भौमिक देवन, लिटिल कंफ्यूजन मैम. भौमिक हैज रिटन लिटिल कंफ्यूजन मैम. सो भौमिक कहाँ पे क्लियर है? अच्छा भौमिक, आप कल के क्लास में नहीं थे ना, that's why you are having difficulties in understanding today's lecture. Okay, so first you refer to what was taught in the what was taught in yesterday's lecture, then you study this topic again, आपको आसानी हो जाएगी. Okay, so those who are present, you have no confusion. So now I'll move on to our next topic. Okay. In last lecture, we have also studied about MMU. Your MMU was Memory Management Unit. Can you tell me what is the purpose of MMU? What is the purpose of MMU?
Reallocating the physical address to logical address.
आपने उल्टा बोल दिया. Allocating the logical address to physical address. Pravesh, it's not physical to logical, it's logical to physical. Okay. Okay. So now others, other than Pravesh, tell me, where do we have logical address and where do we have physical address? Class, tell me, where do we have logical address and where do we have physical address?
Ma'am, CPU at ma'am logical address.
Very good. CPU is your logical address. Now, other than Subhash and Pravas, tell me, where do we have physical address? RAM storage device में क्या होता है? No. Wrong. Krishna also you are wrong. Ram also you are wrong.
मैम मेमोरी यूनिट.
राम और कृष्णा क्योंकि आप गलत हो, सही आंसर सुनना. Others, would you like to try? Where do we have physical address? Class?
Ma'am,
main
memory
memory.
unit.
Very good. Okay, very good. We have in yesterday's lecture I told you this. Sorry. If this is my main memory, okay, so this is my main memory and this is my CPU. CPU is not a memory unit. Okay, so CPU does not has any type of addressing technique. So we generate one logical address which is actually not present. Okay, physically तो है नहीं, logically बस है. So the addressing technique that is used by your CPU is logical address. But main memory RAM तो आपकी you actually have your RAM in your computer and your mobile phone, right? So that means it is physically present. So main memory, the addressing technique that is used by your main memory is called as your physical address. But now we know that for anything to execute, let us say this is my C drive. So C drive means this is your hard disk or secondary storage, whatever you'd like to call. So anything that is there in the C drive, even your calculator, your movie, your photographs, your computer students. So probably you might be having some C compiler. Some of you are doing Python programming. So Anaconda, Spider, R Studio, whatever you're working, all of these programs are there in your hard disk. Okay. For it to execute, by now we are clear that it has to be brought into your main memory. So when it is brought into the main memory, okay, it has to be given some address here because your main memory is huge. It may start from your location 0 to go up to whatever size of memory you have. For example, if you have 16 GB of main memory, 8 GB of main memory, then if you have 1024 MB, but RAM doesn't functions based upon MB, it functions based upon bits and bytes. Okay, so it is huge. So where exactly it resides? So that is your address. So that address of this main memory is fixed. So that is your physical address. So physical address, जिन्होंने भी बोला hard disk, ये hard disk का we have nothing to do with it because execution does not happens in the hard disk. We have nothing to do with hard disk because execution doesn't happens in hard disk. Execution happens in your main memory. Okay, it's very important. You cannot have a computer without memory. Remember, you cannot have a computer without your main memory, but yes, you can have a computer without your hard disk. फॉर एग्जाम्पल योर फ्लाइट सिस्टम, जो हमारे एयरप्लेन्स वगैरह होते हैं, जो हमारा एटीएम वगैरह होता है, दीज आर कॉल्ड एज योर आरटीओएस, रियल टाइम ऑपरेटिंग सिस्टम. केस स्टडी करने के लिए बोला था ना, सो केस स्टडी में एक आपका फ्लाइट सिस्टम ले सकते हो आरटीओएस के लिए, एक एटीएम मशीन ले सकते हो, और कैसे काम कर सकता है, यू कुड हैव एक्सप्लेन दैट. ओके, so now in RTOS, like flight system and your ATM system, we do not have hard disk. This is just for storage, but these has very high main memory systems. Okay, so when we talk about operating system and all, we don't care much about the hard disk. This has very less role to play. We talk about your main memory and your CPU buffer and your cache. This has to be very strong and fine. So physical address belongs to your main memory, logical address belongs to your CPU. Okay, so in yesterday's class, because logical address is not physically there, it's just a conceptual thing. So yesterday we studied about how do we convert this conceptual idea into a physical entity. That means how do we convert this logical address which is there in some numerics like 234, 100, 50, like 324, this concept चाहिए एक नंबर के फॉर्म में जो है. How do we convert this conceptual idea made of some numerics into the physical address? So for that we studied we need a hardware support. That hardware support is your MMU. That means आपका hardware में कुछ होना चाहिए. So that hardware, the name of the hardware was your memory management unit, because we are talking about managing this memory. Okay, so is it clear now? Memory management unit, physical address, logical address. Is it clear? And is it clear why do we need to map this logical address into physical address? कृष्णा, आपको आप समझ में आया कि फिजिकल एड्रेस हार्ड डिस्क का नहीं है, मेन मेमोरी का है? If you'll give me a yes, I will move on with another topic. Okay. So now with this topic, okay, there are few smaller things that you must know. That is, in yesterday's lecture I drew a diagram, okay, wherein I had on this one side CPU, okay, wherein this one side I had CPU. It generates some logical address. इसको थोड़ा बड़ा बना देते हैं. Here I have CPU. This CPU generates some logical address. This we have already studied in last lecture. Generates some logical address. So now this logical address is appended or concatenated, not addition. Don't think this is binary addition, okay? This is either concatenation or appending, okay? Before I use this term, tell me, do you know what is the difference between binary addition and concatenation or appending? आपको difference तो पता है ना? Just write quickly yes or no. If no, write down no. No issue. I'll explain. If you know, quickly write down yes, yes, yes. Subhash को पता है. Girls, do you know? Subhash and Prabhas, okay. Madan, yes. Girls, do you know? Rasmi, Rijwana, and who else? Rasmi, Rijwana, Ridhima. रश्मि, रिजवाना, रिधिमा आपको पता है? ठीक है. अनीता को पता है. गुड. रश्मि, प्लीज एक्सप्लेन शॉर्टली. ओके. Okay, so एक को नहीं पता. Binary addition is simple. Binary addition means if I have address 300, I convert it into its binary equivalent 0000 for this 0, for this 0000, for this 3 I have 0010. This is the binary equivalent of 300. Okay. So now if I have physical address, एक मैंने अगर 14,000 या 14 कुछ लिखा, so what is its binary equivalent? For its binary equivalent is 000. For 1 I have 0001. For 4 I have 0 0. So you perform the addition here. Okay, so 14 3 1 0 0 में करके आके आपका यहाँ पे आएगा 00100010100. So which is 314. Okay, दोनों का addition हो जाएगा. But here we do not perform binary addition. We just perform concatenation. Concatenation is a simple technique of not performing addition byte by byte. However, if I have here 314, okay, then concatenation or appending is 314 के पीछे 14 लगा दो. It is like 314 and 14. Or earlier I had taken the example of 300. So let me take that same example. So when I did 300, if it's binary addition, I'll get 314. But if it is appending or concatenation, that means it is 300 and then after this writing 40. So this is the difference. Okay. So in yesterday's, I think it's clear. Rashmi, अभी समझ में आया? आपने shortly बोला तो I try to keep it shortly. Okay. So let's move on to the topic. So in yesterday's lecture, we studied MMU. Okay. So whatever logical address the CPU generates, it used to be concatenated. This is your main memory management unit. It has some relocation address register, So it will have some value. Okay, it will have some value. So appending to it, we would getting the memory address or the physical memory address. Okay, so now on this, okay, so while this one studying this one, there is something that you must know. Okay, and that is, I need some space. So let me, this is what we have studied in this last lecture, so you just need to remember it. Now with this one, there are few smaller topic, that is your limit register and your relocation register. What does your limit register says is, whatever address your CPU is generating, the logical address, okay, the limit register, the hardware has to check, the hardware will have to check if this address generated by your CPU is lesser than or equal to, if it is lesser than or equal to your limit register. And in one of the lecture, I told you limit register is the register that belongs to your main memory. And this logical address must be lesser than your limit register. Why? Limit register checks, okay, physical memory has a fixed memory size. Let us say if it goes from 0 to 100, and if your CPU is generating 300, that means it is greater than 100. So we do not have any physical address that is greater than 100. That means this is a wrongly generated logical address and it should not be accepted. If it is not lesser, if it is not lesser, for example here it is not less, then it should generate some error. You should design your address in such a way. Okay, so this is your address error. So now if your limit register is less, okay, if your limit register is yes, then only you should allow, remember the diagram relocation ho raha tha, okay, so then only you should allow the appending or the concatenation of your logical address with your relocation register. Okay, then only you will generate the physical address come. This is your main memory, then only you should generate your physical address. So this conditional checking statement must be present in your MMU, and it must be checked constantly while you are performing swapping also. But for this, we need hardware support. We cannot do it physically because here register is involved. Register means hardware support. Okay, so this is the type of hardware support that should be there. So is it clear? If yes, I'll move on to the next topic. If yes, write down yes quickly.
Yes, ma'am.
Okay. Should we take 5 minutes break or can we proceed with the next topic? It's 1 hour and initially you got scolded also. So 5 minute break लेना है या can I continue? Okay. Thank you everyone. So now next topic is a new topic from your main memory management. Okay. It involves numerical calculation and also I find it interesting and easy to understand. इसमें जैसे इसमें बहुत सारे, there are various smaller things that is involved, various logical things to correlate. So sometimes it may get confusing or it may get over your head. Okay, if not explained clearly. But the next topic that we are going to study, I find it simple, easy to understand, and also because it's numerical, so you will be able to score your marks. In competitive exam also they give problems. So if you know this problem, your possibility to score the marks is 100%. Okay. So let's do a bit of your theory, then we'll move on to the numerical. Okay. So now let's go to your memory allocation. Memory allocation. And before I do memory allocation, let me do a comparison. Earlier, we had only one CPU, or we may have multiple CPU, but only one process in each CPU. So we had to do what? What do we have to do? Because we have multiple process ready to use the CPU, but we have restricted number of CPU. So to let all the process execute in the CPU, what did we do? We had to do? What was the concept? Anyone, please? Anyone from the girl? Anita, Rashmi, रिजवाना रिजवाना आप काफी एक्टिव रहते हो. You can try to answer. Rashmi is also quite interactive. We had only one CPU, but we had multiple process. So to let all the process execute in the CPU, what did we do? If you cannot answer, write down no. If you are trying to think, then write down yes. Yes or no? No. Okay. Rijwana? Yes, ma'am. What is it, Rijwana? Can you try? Would you like to try? Very good, Ram. We did scheduling. Very good. We did scheduling. We scheduled different processes. We created a timetable. Remember Gantt chart? And we told from here to here, P0 you execute. For this time period, P1 you execute. For this time period, P2 you execute. We created a timetable called as Gantt chart, depending upon the algorithm. Okay. So what was the process called? The process was called scheduling. Okay, the process was called scheduling. Very good, Ram. Okay, so now we have to do something like that with our main memory. So the process of doing this technique with the CPU is called as your scheduling. scheduling. Okay, one process per CPU at a given point of time. Now we have main memory. Here I have kernel, and here I have user space. But this user space is limited. And sometimes it may happen so that you have only 1 GB, 2 GB, 4 GB of your computer's RAM. However, you have 16 GB of data to be exit. Does that mean your computer will not process it? No, definitely it will process it. But we have only, let's say kernel has occupied 1 GB out of your 8 GB. Now you have only 7 GB. So how do we allocate this memory? And by now we know that anything that wants to execute that is there in your secondary memory, it must be brought into the main memory. By now we know that. But I have now 16 GB of data and I have only 7 GB of user space. How should I do that? For that, I have my memory allocation. And also, if now instead of this, we may have other situation like if I have 4 processes, P1, P1, P2, P3, P4. Okay, I have 4 processes, or I have only 3 space, or I have 4 space. If I have 3 space, then how should I allocate memory to this 4 process? And if I have 4 process only and each memory space of 1 GB each, But now it needs 2 GB, it needs 1 GB, it needs 1 GB, it needs 1 GB. So how should I allocate these memory spaces to these processes? How should I do this? Okay, so if it was CPU, we call it scheduling, but now because it is your main memory, so we call this technique as memory allocation technique. Okay, so now this memory allocation technique along with it brings few smaller definition based topic. So let's discuss that first. But before we move on to that, quickly write in the chat box, is it clear what is your memory allocation and what are the various problems associated with your memory allocation? Write in the chat box very quickly. Okay, so it's your memory allocation is clear. So let's study what are the various memory allocation techniques. Okay, so we have basically two types of memory allocation technique. One is your fixed partition based method, another is memory vector method. Okay, memory vector method. What is your fixed partition method? It's very simple. You have your main memory here. So let's say this is your kernel. So let me take an example. You have 8 GB of memory. So let's say like 1 GB of memory is taken by the operating system itself, and you have part remaining is your 7 GB. So now for this 7 GB, if your memory is divided like this, 1 GB for partition 1, 2 GB, let us say this is your 3 GB, that makes it 3, 4, 5, 6, and 1 GB. And if it is fixed, that if it can never be changed, I cannot make this as 2 GB and I cannot make this as 4 GB, or I cannot make this as 5 GB. And if I have 5 GB of requirement, and if I cannot put them all together, 1 GB, 2 GB, 3 GB, and make it as 5 GB, that means if it is fixed, if this partition is fixed and we have no authorization to manipulate this partition, then this is called as your fixed partition based memory allocation technique. Okay, so another is your memory vector table. This one is, now again I have the main memory. Okay, I have here main memory. Now this is my kernel. Let me take that same example of 8 GB. So according to that, 0 to 1 GB is taken by my operating system's kernel. Okay, so remaining is my 7 GB. Okay, so remaining is my 7 GB of address space. So now this 7 GB of address space is not partitioned. So this acts like a pool of memory. We call it as pool of memory. Okay, so ये एक pool है. ये एक pool में I have got 7 GB of memory. So I maintain a table for it. Okay, from 2 to 8 GB location I have free, because from 0 to 1 GB it's occupied. Okay, so I have this pool free. So whenever requirement comes, if 1 GB comes and I'm giving this area from the pool to 1 GB and I'm sending it here, so 1 to 2 to 1 GB. So from this pool I am maintaining a table. So in table 1 I have made a row entry 0 to 1 given to process P1. So let us say now process P2 comes with memory requirement of 3 GB. So in this pool 1 to, because it needs 3 GB, so 1 to 4 GB process P2. So 2 to 2, 3, 4, 5. So you have 5 the process P2 has taken. So now it has taken 3 GB, it has taken 1 GB. So 3 plus 1, 4 GB we are done. Okay, so as the request comes in, it will create that much. So now by when it will be clear, so when process P1 and process P2 is done using it, okay, if they have finished, if these processes are terminated, again a big address space is created without any form of partition. The partition is logically created according to the request received for different size based processes. Okay, so this is called as your fixed partition based and memory vector table. Vector table because we have to create a vector table to let find, let me create, write it down in a clear space. We need a vector table because memory as a big whole is there. So I need to have a table, Memerica, where I can say from what, let us say 1, 0 to 1 kernel is there. So this is your table. Okay, so 1 to 2, let us say process P2 is there, and process P1 needed a big space, let us say 5 GB. So P3, okay, 2 to 5 GB needed, so 2 to 7 I have process P3. So this is a table, this is not memory, so I need not know, so I need not make this big because entry in the table is fixed, each row size is fixed. Okay, but here I have 2 to 7 address space for P3. So no address table, no memory table, no memory table. If you are asked in the exam, fixed memory partition requires memory table. No, it doesn't, because your fixed partition is there. But memory vector table, fixed partition is not there, and address pool is there. So we need a memory table to find the address where in the physical address process P1 is there, where in the memory process 2 is there, where in the memory process 3 is there. So is it clear? Fixed partition based and memory vector table. Okay, thank you everyone. Now, the next smaller topic. Now, this word you need to remember like bread and butter. You have to remember this word all the time, okay? Because it will be I'll be using continuously in the future topic. Contiguous memory. Do we call it location or allocation? Let me see in the book. Acha, allocation. Contiguous memory allocation. Okay, contiguous. There is something called as contiguous memory allocation, and other topic we don't study because it is non-contiguous memory allocation. Okay, contiguous memory allocation or non-contiguous memory allocation. So let me explain what are these topics. Okay. Okay. So now let me draw an example of the main memory again. Try to recall, when I was teaching you processing, I used to continuously draw the diagram of CPU. Now I'm teaching you memory allocation, that's why I'm continuously drawing the diagram of your main memory. Okay. So what is contiguous memory allocation? I'm leaving it for the kernel. Let us say 0 to 10 bits. Okay, your total memory bits is, let us say 1 MB. So I have 1024 bits of the memory. What is contiguous memory allocation? If process P1 comes, listen carefully. If process P1 comes and it needs, let us say 10 KB of memory. It needs 10 KB of memory. Okay, so 10 KB of memory means How many bits? 10 KB of memory means okay, tell मैं खुद ही confused हो गई. How much is it 10 KB of अच्छा, it is in bits, no? So that means it is 1 kilobyte is equals to 1024 bits. ना मैंने इसको bit बोला ना, so it is not 1 MB, it is actually 1 KB of your memory. So I cannot have 10 KB. So let me write down here. 20 or 24 bits. Process P1 comes and it needs 24 bits of the main memory. Okay. So now if process P1 is given 10, 11, 12, 13, 14, 15, 16 and up to 24, then this continuous memory segment is called as your contiguous memory allocation. If I can allocate a continuous memory to one process P1, then we call it as contiguous memory allocation. Okay. So now what is non-contiguous memory allocation? So let us say your partitioning is something like that. Now this one is occupied, this one is free, this one is occupied, and this one is free, or if this one is also occupied. And let me take one more block here, something like this. So now this block is free and this block is free, but these are not contiguous. They are randomly, this free space is randomly located in different location of your main memory. Then it is called as your non-contiguous memory allocation. Okay. So now let us say instead of 24, it is your 14. Okay, so here I have 14 bits of memory free. So let's say this is your let me say this is your 50 and this is your 70, let me say. Okay, so how much is free now here? 20. This is your 50 bit, this is your 70 bit of address. So that means I have 50 bits, 20 bits of free address here. 20 bits of free address. P1 needed 24. But are these continuous? So can I store it? So now whether can I store it or not is a different question. We'll see it later. According to algorithm, we will decide that. But for sure, this memory, 14 bits of memory and this 20 bits of memory is not continuous in nature because they are spread at different location wherein in between some process had occupied that location, continuous location. So if I am to consider this is your 10 and this is your 4, let us say this is your 10 and this is your 14. So 10 to 11, 11 to 12, 12 to 13, 13 to 14 is your continuous. This much is your continuous. But from 14 directly to 15 something is occupied. So this is not continuous now, contiguous. Again contiguous will go from 50, 51, 52 to your 70. So now if free memory allocation is there one after another, then we call that technique as contiguous memory allocation. And if it's not free, if I have something like this and occupied and then later on free space, then we call it as non-contiguous memory allocation. Okay, so is it clear or not? Subhash, not clear. Okay, Subhash, कौन सा contiguous? I think दोनों ना. Others, is it clear? Ram, clear. Okay, Madan, no. Others, is it clear? Madan and Subhash को तो समझा नहीं. Rojas, okay. I think most of you are not clear. So let me. This is your diagram for main memory. Okay, so let's say this memory, the size of this memory is let's say 8 GB RAM. Okay, 8 GB RAM. So now that means, let me say that this memory is like 0 to 1 GB is occupied and 1 to 8 GB is free. Okay. Now there are different processes that has resided in this memory. So let me say P1 0, let us say 1 to 2 process P1 resides in the main memory. Process P1 is there in the main memory. Okay, in the location 1 to 2. So let me say here like 7 to 8. Let's say 6 to 8 actually. 2 GB process P3 is there. Okay. So now I have here, let me do one more partition. Let's say 4. 2 to 4, no, it's free. 4 to 6, it's free. Let's say like that. Okay. So now what is contiguous memory allocation? If process P2 is the P2 comes, okay, if process P2 comes and it needs 3 GB of memory, if process P2 comes and it needs 3 GB of memory, and we are able to allocate contiguous memory allocation 2 to 6, if we are able to allocate it, then if you see here, it is contiguous 2 to 4, 4 to 6, it is placed one after another. Then assigning this 2 to 6 block to P2 is called as your contiguous memory allocation, because another memory block 4 to 6 block is sitting right next to first memory block 2 to 4. This is called as your contiguous memory allocation. Now, instead of this situation, if we have something like this, if we have something like this, 2 to 4 I have here. Now, let me say I have here P2 already there, occupying 4 to 6. Okay. So now P3 comes in, same thing, it needs now 3 GB of memory. It needs 3 GB of memory. If you'll see here 2 to 4, that means 2 GB is free. 6 to 8, 2 GB is free. Can we now accommodate this P3? Because if you no, depending upon no, depending upon one situation, yes, if we allow some algorithms like that. First let me explain. Initially no. Why? Because we do not have 3 contiguous memory free. This one is occupied, this one is occupied. So now 2 to 4 GB is contiguous, it's free. But now this one is occupied. So now what is the free space? 2 to 4, but not 4 to 6, rather 6 to 8. If we had like 2 to 4, 4 to 6, then it is your contiguous memory. Okay, so we could allocate P3 into this contiguous memory allocation. But now 4 to 6 is occupied. It is not free. So I have here 2 to 3, 1 block free, and 6 to 8. Is it contiguous? क्या ये continual value है? Is it like 2, 4, 6? Sorry, 2, 4, then 6, 8. Is it continuously free? No, because 4 to 6, 4 to 6, it's occupied. Okay, and then we have 6 to 8 free, 2 to 4 free. We have medium 2 to 4 4 to 6 occupied. Okay, so such memory allocation which is not continuous, and we cannot allocate P3 as a contiguous memory. We have to allocate it in 2 different memory, wherein the memory is blocked by some other process in between, is called as your non-contiguous memory allocation. Allocating memory to the process, okay, allocating memory to the new process, but not in continuous fashion like here and here, but in non-contiguous fashion like here, and then breaking that process in half and allocating it to a different location wherein the memory or physical address of the memory is not contiguous. Is it clear, or should I take one more example? रिद्धिमा, ये एक आई डोंट थिंक द वर्ड इज फिट्स. It's a controversial question, or actually controversial is not the right word to use. It is based upon application, money and all. Okay, so what do I mean by that? Okay, सबका क्लियर है? तो लेट मी रिद्धिमान बोरा, टू योर क्वेश्चन डायरेक्टली मैं आंसर कर देती हूँ. वी कैन नॉट कमेंट विच वन इज बेटर. Okay, the right answer is we cannot comment because it is entirely based upon cost, money and all. How? Let me clear that. With the help of an example. लेकिन अगर मुझे आपको क्यों, कैसे, कहाँ बताना नहीं है, यू जस्ट वांट टू नो मैम मुझे इनसाइड स्टोरी नहीं जानना, इतना लंबा नहीं खींचना है, मुझे डायरेक्ट आंसर चाहिए, then the short and sweet answer is no comments. We cannot comment on this. Okay, there is nothing called as which is better. It is entirely based upon the application. Okay, so Ridhima, will this much is sufficient, or do you want to know why, ma'am, why cannot we say which is better? Do you want to know the reason, or the answer is sufficient? We cannot comment which one is better. Okay, okay, Rinduman ko answer is sufficient. Okay, then let's not go into why. So simply, both of them are better on their own ways. Okay, and both of them have disadvantages on their own ways. So that's the answer. Okay, then now the next topic that we are going to study is various memory allocation technique. Okay, so what are the various memory allocation algorithms based upon which, when we have different requests received from different processes, then how do we assign, which should we get, like scheduling, we had algorithms like SJF, SRTF, FCFS, priority, RR. So what are the algorithms based upon which we should allocate memory to the different processes? Okay, so that depends upon the algorithm. Okay, so there are various methods of allocating main memory. Okay, so the three that we are going to study in this classroom is, first is your first fit. Second is your best fit. Third is your worst fit. Okay, first I will explain to you algorithmically or the theoretical aspect. Second, after I explain to you the definition of this one, आप लोग pen and paper ready करोगे and we'll solve one problem. Okay, and then you will have to write programs to implement each one of these. Okay, runtime. You will just like you implemented various scheduling algorithms. You will ask from the user different memory partition. You'll ask from the user which one they want to do, which method they would like to choose, first fit, best fit or worst fit. And then you'll also have to give the size of the processes, and then depending upon the algorithms you'll have to show which process will be allocated to which memory allocation. Okay, so let me explain first fit. First fit is simple. Actually all of them are simple. First fit says that whichever is the first big hole, if I have 5 memory allocation, if I have 5 process, or if I have 4 memory allocation and I have 5 process. Excuse me. Hello? Okay, sorry class, sorry for that. So now we have three techniques to do it. Okay, the first is your first fit, second is your best fit, and the third is your worst fit. Okay, so now there could be different situations. Okay, equal to like five memory allocation, five processes, four memory space, but only only four memory. Let me write down. This is your memory. This is your memory. This is your process. Okay, or number of process, memory, slots of memory. We will write down how many memory slots. Okay, slots, by that I mean if this is your main memory, how many slots are free, like that. Okay, so if there are five slots and five process, or there could be only four slots available, five process request, or there are five memory slots free, and we have only four process. But this is not the factor that will impact the algorithm. Okay, the other important factor is it may happen so that the slots that you have available are only of size 1 GB. However, the process request that has come is of 4 GB, 2 GB, 3 GB, or like some KBs and all. Depending upon this various factors, how do we allocate these many processes with variant sizes to the memory we have? Okay, so that depends upon the choice of algorithm: first fit, best fit, and worst fit. So now amongst these three algorithms, we cannot say which one will be the best algorithm in general. No, we cannot say that. It depends upon various factors, sizes, numbers, etc., etc. So you just have to find, calculate all of these three, and for the given scenario, which algorithm would be best to implement or use in that particular time. Okay, so now what we will do is we'll study one by one all of this, then we will solve numerical to understand how it actually happens. Okay, but first fit says whichever process comes first, see which one is the biggest space available and give the first coming process the biggest space available. Okay, that is your first fit. Now what is the best fit? The best fit says that if a process, whatever process request you have received and whatever memory holes you have, give the process the smallest memory hole that is big enough to save that process. Okay, that is your best fit. That means process give the smallest hole that is big enough to store that process in the main memory. What is the first worst fit? The worst fit says whichever process request comes in, allocate the largest hole to the first received process request and then proceed further. Okay, so these are the definition which may by definition or by constantly giving you the explanation of these three, you might not have been able to understand it fully. So let's do one thing. Okay, let's take one example algorithm or problem and solve it, then you will be more clear to it. Okay, so do you guys have pen and paper handy with you? Can I write the problem statement? Okay.
Yes,
So
ma'am.
write. Okay, thank you. So write along with me the problem statement. Okay. Oh, sorry, I have to share it now. Given five memory partitions given five memory partitions of 100 KB, 500 KB, 200 KB, 300 KB and write along with me, okay? Write the problem statement along with me. 600 KB in order. That means in your main memory, this is the order in which your free memory are available in order. Okay. So now the question is, how could you? Sorry, how would each each of the first fit, first fit, best fit, and your worst fit? Given 5 partitions of 100, 500, 200, 300, and 600 KB in order, how would each of the first fit, best fit, worst fit? Okay. Algorithms place processes of 212 KB, 417 KB, 112 KB, and 426 KB in order. Which algorithm makes the most efficient use of memory? This is your question. Chaluliko, when you are done writing the question, write in the chat box. Done. Then we will start solving it. Done. Okay. Thank you. So let's solve it. Okay. I hope everyone is done. 1, 2, 3. Done. Okay, that's done. Ram is done. Madan is done. Subhash, Rajesh, Prakash, Rashmi, Krishna. Okay. Rijwana and I think Nita or Rita. Anita. Rijwana. Who else? Rojesh. Are you guys done? Vidhiman done. Okay. Rijwana. Rojesh done. Okay. Rijwana. Acha, hand. Okay. So I think everyone's done now. So let's proceed. Okay. Sorry. So now pay attention here. Let me explain the question first. Okay, let me explain the question first. The question says, now I'm not going to write the kernel, okay? I need space and the question has occupied some space. The question says, I have 5 memory partitions. 1, 2, 3, 4, and 5. This has been asked in various competitive exams. Okay. Question says I have 5 given memory partition of how much? Of 100. This block, this is my main memory. Okay. This is my main memory. First block is 100 KB. Second free space is 500 KB. The third is 200 KB. The fourth is 300 KB. And the fifth one is 600 KB. And this free block is placed in order. That means after 100, 500 is free. After 500, 200 is free. That means the line here represents that it is occupied. Whatever is there, it has been occupied by some process, or it may not be. There could be two possibilities. Either it is fixed memory allocation, जहाँ पे partition है, or if it is memory vector, that means some process has occupied it. But in this case, we have nothing to do with these two situations. Okay, we have just been said कि यहाँ पे 5 block available है ऐसे, and they are in order. 100, after that 500, after that 200, after that 300, after that 600. Now the question is, how will we assign these free spaces to these processes with the help of first fit, best fit, and worst fit, and which algorithm will be the best one, or which algorithm will make the optimum use of memory? कौन सा algorithm memory का अच्छे से use करेगा? Okay. So what are the process size? So I have process P1 of 212. I have to clear this part to solve this problem. So if you think, draw it right now. Okay, right after I'm done, I'll clear it so that I can do the solution. So I have process P1 of 212 KB. I have process P2 of 417 KB. I have process P3 of 112 KB, and I have process P4 of 426 KB. In order means these process have come to the main memory with these priority. That means first P1 came to the main memory, then came the P2, then came the P3, then came the P4. So now we have to place these processes in this memory. Okay, so 0 to 100 free है, 100 to 500 तक, मतलब 500 free है, मतलब let's say 600. ओके, फिर 200 फ्री है मतलब 800, 300 फ्री है मतलब 1100, 600 फ्री है मतलब 1700. Okay, so these is the sizes that are free. 0 to 100, 100 to 600, 600 to 800, 800 to 1100, 1100 to 700. These memories holes, we also call it as hole. Okay, these holes are free, and these are the process requests: 212, 417, 112, 426. Now we need to put these in this memory in such a way that we should be able to accommodate all of these into this main memory. Or the question is, will we be able to put these processes into the main memory? Okay, क्या हम एक ही साथ इस सारे प्रोसेस को यहाँ पे डाल सकते हैं? The question is that with the most efficient use of memory. Okay, so now we'll have to solve it. Is the question clear to you? Can we move towards solving the problem?
Yes, ma'am.
Okay, then let's move. Okay, so we'll go for first fit first. Just draw this one. We'll go for first fit. I'm going to clear it because I'm going to need this space. Do it along after we finished first. I'll give you some time, and because the space is limited, I'll clear first fit. I'll allow you to write it. Then we'll do the second. Okay, the first question is first fit. So let's read the definition of first fit first. What does the first fit say? Allocate the first hole that is big enough. Okay, allocate the first hole that is big enough. So what is the first process that has come? 212. So now when you implement this, you'll have to use searching algorithm. Okay, when you implement it, you have to implement searching algorithm. So your variable is 212. So you will start searching. Which one is the first big hole? So we'll move from here. Can we put 212 in 100 KB of memory? No. Can we put 212 in 500 KB of memory? Yes. Okay, yes. So the first fix says whichever is the first big hole, whichever is the first big hole for that process, put that process in that particular memory. So what do we do now? We put we put 212 KB. We put 212 KB in 212 KB is put in 500 KB of partition. Okay, 212 KB को 212 to have 212 KB of process. Let me write down size of process is put in 500 KB partition of memory, because this is the first big hole to accommodate this one. So this is what first fit does. Okay, so now which one is the second? Second is 417. The second process that has been submitted to the main memory is 417 KB. So now 407, again you will do the searching. Can you accommodate it here 100? No. Okay. So after 500, okay, here how much of the memory is left? Deduct from 500 to 112. How much is left? 500 में 200 गया, 300, 300 में 10 गया, 290, 290 में 2 गया, 218, 28. So 288 KB of memory is left now. Okay, so when we put 212 in 500 KB, so 212 is put here. So from 500, now how much is the remaining? 288. So when 417 comes, can we put 417 in 100? No. Can we put 417 into, now here only 288 is remaining. Can we put in 288? No. Can we put 417 in 200? No. In 300? 288? Yes, we can put 288. We can put 417. So can we put it in 300? No. So can we put 417 in 600? Yes. So the first big hole, when second process with size 417 came, according to first fit, the first big hole that can accommodate 417 according to our searching algorithm is your 600. So now here we put so here now I'm going to write it in shortcut now. I'll not write everything. So now your 417 K is put in 600 K memory. Okay, 417 is put in your 600 K memory. Is it clear? Is first fit clear? Take the first process in order. Search your free memory allocation. Find the first biggest hole that can accommodate the process. Then accommodate it. Remaining whatever is there, deduct it, keep it. So that becomes the remaining. Again, for the next process request, search from the starting. Find the first biggest hole. Put that process in the first biggest hole. Okay, proceed it as far as you can go. Is it clear? First fit?
Yes.
Yes, ma'am.
Okay.
Yes,
Okay.
ma'am.
Okay. So now how much is the remaining now? How much is the remaining here? 600 में 400
183.
183. Okay. Thank you. 183 a left. Okay. So now you solve me and give me for 112 and 426 for first fit. First fit के लिए ये दोनों देखो. अच्छा 417 is done. So give me for 112 and 426 for first fit. If you think there is any confusion while solving it, do not hesitate. Just ask me. मैम ने डांटा तो नहीं पूछना, ऐसा नहीं करना है. आप मेरे बच्चे हो, डांटूंगी भी, फिर प्यार से समझाऊंगी भी. तो डरना नहीं है, बस फ्रीली पूछना है. और हाँ, क्योंकि बड़ी हूँ तो जो बोल रही हूँ वो आपको मानना भी है. तो अभी सॉल्व करो. समझ में नहीं आया तो बिना डरे पूछो. 10 बार पूछो, कोई प्रॉब्लम नहीं. आई थिंक हमारे पास कितने प्रोसेस थे? 4 प्रोसेस थे. Out of 4 processes, 2 processes has already been given the memory location, and they are already gone to the memory now. They are there in the RAM now. So now 2 are remaining. So using first fit, tell me which memory hole 112 will go, which memory hole 426 will go. So if you are done, write down done, then I'll ask you. Okay, Ram is done. Okay, so Ram, ek do or let's wait for one or more done, then we'll discuss. Okay, let's wait for your friends as well. Madan is done, so I have got 2 done now. Girls also, please participate and try to be quick, girls. One more done from girl, then I'll move forward. Thank you, Rishwana. Okay, so let's discuss now. So now let's go with the ladies first phrase. Let me do. Okay, so Rishwana, the next process that has to be given the memory allocation is the process P3 with the process size 112. So now Rishwana, tell me 112K is put in which memory partition? Rizwana, आपको unmute करना पड़ेगा. Okay, I cannot see the chat box right now. So you'll have to unmute yourself and give me the answer. 112K is put in which memory partition?
Ma'am, 200 KB.
200? Rizwana, which one? 200? Okay, write in the chat box. Rizwana, 112K is put in which one? Rizwana, okay. So now Madan, Ram, you also tell me 212 will be put in which memory allocation? Ram and Madan also?
500.
Ram, 500 is not there now. 500 has become 288 now.
Ma'am,
Yes?
288.
Very good. Okay, Subhashana. Yes, Ram, you are correct. Rijwana, you are wrong. Okay, so Rijwana, pay attention. How you are wrong. Okay, others you are correct. Yes. Now 112 will be put in Ram. In exam, you cannot write 500 because now 500 has been updated with the value 288. Now in the memory, there is no free allocation as 500. There is only free allocation as 288. So Ram, in the exam, to make you confused in competitive or in university exam, आपको कंफ्यूज करने के लिए they may give you both option 500 and 288 for 112, but the correct answer is 288. Okay now? So now Rijwana, the first definition for the first fit is allocate the first whole that is big enough. So now, can I put 112 in 100? No, it is not big enough. Can I put 112, 500 ko kato, 288 lekho? Can I put 112 in 288? Yes. Now this is the first big hole that can accommodate 112. So now 200 can also take 112, but this is not the first big hole. This is the second big hole. So your searching goes from starting and stops when the first request is served. Sorry, when the first need is served. So 112 is put in 288 A memory. Okay. So now other than those who have given the right answer, other than Madan, Ram, Subhash. Okay, Ram, Madan, Subhash को छोड़ के कोई और tell me now where will 426 go? Okay, first we'll have to complete this one. No? Now what is the whole size? Now what is the memory left? 112. So 100. 112.
176, ma'am.
100, yes, 176K is the free now. Okay. Okay. So other than Subhash, ये जिन्होंने अभी दिया, please tell me now where will 426 go? Pravesh Basnet 200. Okay. Others? Others? Okay. No, everyone can answer. Everyone can answer. Rijwana, Ram,
Ma'am,
yes.
300. 300.
300. Actually, it will not go anywhere. Why? 426 is a process, okay, of size 426. Now, what is the different memory size? We have now 100. We have now from here only 176, 100, 176. I think from here 200, 300, and from here 183. So now none of this whole can accommodate 426 now. So now 426 will have to wait. According to first fit, it will wait. 426 must wait. Is it clear now? 426 कोई भी whole big नहीं है. 288, 183, 176 and 100, I think 200. So none is big enough. So it will have to wait. Is it clear? Is first fit clear?
Yes, ma'am.
Okay,
Yes, ma'am.
okay. So class, because we are already discussing it now, best fit and worst fit definition कर लिया. ऐसा ही इतना छोटा सा ही numerical है. Each of the algorithm might take 5-7 minutes each. So maximum 15 minutes will finish. अगर कल करेंगे तो फिर से starting से start करना पड़ेगा. So can I take 15 minutes extra and finish it, or are you exhausted? Should we leave it for tomorrow?
Yes, ma'am. You can take.
Can I continue?
Yes, ma'am.
Okay, so Madan, let's wait for more number of your friends. Let's see if they can also continue. Thank you, Madan. Others? Okay, Bomi continue. Okay, thank you. Okay, I'm going to wait for one more. Okay, okay, Subhash continue. Girls, can I continue? Rojesh, Prakash, okay, everyone is saying I can continue, so I'm going to continue. Okay, so if anyone is having trouble understanding or think you're exhausted, just unmute yourself and stop me there. I'll stop. Okay, so I hope now first fit is clear now. So now I'm going to clear this part. I will be needing it for your best fit. Okay. Okay. So now we have the second one is your best fit. Okay, so let me read the best fit again. Allocate the process to the smallest hole that is big enough. Matlab, when a process request comes, start searching for memory partition from starting to the end. That means perform searching for all the different partitions. Out of this, find the smallest that is big enough to store that process. That means for every process that comes in, for example, for first fit, you start the searching. Whenever you find the first one, you stop your searching there. You allocate the memory. For second request, you start searching from first. You stop when you find the big enough. But in best fit, every time the program that you will be writing will have to start searching from the starting, and the searching will go up till the end. Okay, amongst all, it will choose which one is the smallest. That means you'll have to take a temporary variable, keep swapping every time it gets smallest big enough. Okay, then we do it. So let's go for best fit now. So the first one is 212. So 212 goes to 100. It cannot accommodate, so it cancels. Okay. So 212, 500, yes, it can do. But right now it will not put in. It will search till end. Can we put 212 in 200? No. Can we put 212 in 300? Yes. Can we put 212 in 600? Yes. So now between these three, now your best fit, after searching, you will perform comparison algorithm. You will compare out of these three, which one is the smallest. Compare 500 with 300. This one is smaller, so you choose this one. Sorting you will do. 300 to 600, which one is smallest? 300. So what will you do now? Now this one is the smallest that is big enough to store 212. Okay, so now you will store 212. Okay, so now you will store 212 in 300. Okay, so now I'm going to remove all of this so that we can use it for next. Now we'll store 212 in 300. So what is the remaining? 88. Clear? Clear? And also how will you have to implement it in program? Abhi aapka ye तीनों lab programs also. This is also your lab aim. Okay. So is it clear? The first one?
Yes, ma'am.
Okay. So
Yes,
let's
ma'am.
try. Okay. So let's try one. Okay. Should I go with the second one, or would you like to try on your own? Would you like to try, or should I solve one more?
Ma'am, one more.
One more, Rijwana. Okay. So now we are done with 212 now. Okay. So the next request is 417. So now for this 300 is gone, and now we are left with only 88. Okay. So now 417 comes. Start searching from starting to end. Can we put 417 in 100? No. Can we put 417 in 500? Yes. Can we put 417 in 200? No. Can we put 417 in 88? No. In 600? Yes. So you start searching from when you implement it programmatically, you'll perform searching from starting to end. In whichever it can accommodate, you will store all of them. At the end, you can approach two ways after this. You can perform sorting of this one and select the first, or you can perform comparison, swapping and comparison. These are the two ways you can implement in program. पर अब यहाँ पे कैसे होगा? Now we have two. Okay, Rijwana, 500 and 600 can be memory allocation. That means this is your memory. Here I have a memory size of 500 in main memory. Another is your 600, let us say. This is your main memory. These are the two. This is the process. Let me call it process P2 because this is P1. So it is of size 417. So in which memory allocation operating system will put? So if operating system is using best fit, so now best fit may which one is the biggest? So the out of these two are the biggest. So now out of these two biggest, which one is the smallest to accommodate this? So 417, this one is the smallest, that is big enough. This is the smallest that is big enough to store it. So can we store 417 here? Yes. Okay, so we go here. So now, is it clear, Rizwana? Now we put 417. Okay, अच्छा यहाँ पे clear नहीं किया ना मैंने. So now we put 417. 417 can be put in 2. Okay, but out of these two, which one is the smallest that is big enough to accommodate this? So the answer is 500. So 417K is put in 500K of memory. 500K of memory. So how much is left? 17, 20, 20, 80, 83K left. Is it clear, Rizwana, now?
Yes, ma'am.
Okay. So now please try for the other two, 112 and 426. If it's done, okay, Subhash is saying done. Okay, Subhash, tell me 112 will be put in which one, which memory partition?
Ma'am, 200.
Very good. Now your 112 will be put in 200 memory partition, and how much is left?
88, ma'am.
I think it is 88 only. Okay, so now I'm going to write here in shortcut. Now can you tell me, can we accommodate 426 according to best fit? Like in first fit we could not accommodate 426, it had to wait. Here, does 426 has to wait?
No, ma'am.
No, very good. Okay, so now it can also start processing. Okay, so where do we put 426?
600.
600. Very good. So how much is left now?
174.
174. Is it correct? 426 means 30, 70, 40. Yes, 174. Okay. So is best fit clear with everyone? Can I move with worst fit? This is the last. Worst fit is the last. Is best fit clear with everyone? Have all of you got got the same answer?
Yes, ma'am.
Okay, thank you, Prabhas. Rashmi, thank you. Ram, आपका आ गया? Any confusion, Ram? Prakash, okay. Okay. And बाकी कौन है? Ram, Rajesh, Pravesh, Subhas. I think Subhas ने आंसर दिया था.
Clear,
Okay.
ma'am.
Okay. राम और सुभाष और प्रवेश में मैं थोड़ा कंफ्यूज हो जाती हूँ. कृष्णा, is it clear?
Yes, ma'am.
Okay, so let's go with the last memory allocation technique of the day, and that is your worst fit. Now we have worst fit algorithm. Okay, so let me clear this one first, then we'll talk about worst fit again. Okay, so what does your worst fit algorithm says? Okay, your worst fit algorithm says allocate the largest hole. That means the intention here is to create the largest hole possible, so that if we get more process in the future, then we have as big, because let's okay, if this is my memory and I have scattered smaller hole in different places, different fragments, can I use it? No. Okay, it is like saying, let's say this is my huge bread. Okay, so according to first two algorithm, what do we have? According to first two algorithm, first fit and best fit, we are creating smaller fragments in different location. We are distributing the bread to different persons in such a way that we have at the end left smaller pieces of breads. We are left with smaller pieces of breads. But worst fit says, instead of creating smaller holes, let's create big hole. बड़े hole बनाते हैं. So that if I have smaller pieces of bread, okay, can I give this to anyone? No, I cannot. But if I have created a big hole, let's say now I have the same bread, that is your main memory. I gave this, this like this. Now I'm remaining with this portion of bread. Now if Rijwana comes to me, ma'am, I'm hungry, do you have anything to eat? Yes, I have. Now if I give this to Rijwana, she will feel insulted. But if I'll give this one to Rijwana, she'll feel, yes, yeah, ma'am gave me lunch to eat. She'll be happy. Okay, so the intention of worst fit says, instead of creating smaller hole, let's create a big hole, so that in future any process comes, we will have a big hole to provide. Okay, so when a process comes, give the biggest hole that is available. That is your worst fit. Okay, so let's see it numerically. When we implement it, how efficiently it works. Okay, so now again in order, we have the 212 first process. Okay, so now it will have to perform searching from the starting to the end. Okay, so 100 and 500, it will start from 100. So is 500, it will constantly perform comparison and searching. Okay, so if the second is being, I think it work, you can implement. I'm getting confused with different searching technique. अगर शायद ये बबल सॉर्ट यू कैन यूज इट, क्योंकि बबल सॉर्ट है या क्विक सॉर्ट है जिसमें बड़ा मिलने पे पहले का कैंसिल होता है. यू कैन चेक. ओके, so that way you can implement. So 100, 500 is big, it will cancel this one. Okay, now already I have big one. So 500, 200, 500 is big, so I cancel this one, I move with 500. 500, 300, it will compare which one is big, 500, so it will remove it. So if I had a variable, so I still have 500. So I'll again compare 500 with 600. Now which one is big? Now 600 is big. So now it will replace 500. It will delete 500. It will delete 500. Now it will put here 600. Because this is the biggest one. Okay. So now 212 will be put in 600 now. So how much left? 200, 200, 600, 400, 400 में 10, 400 में 10, 390, तो 328. I think if I'm wrong, please correct me. I think 388. Is it clear? Is worst fit clear? Should I take one more example? Is it clear, or should I take one more example? Find the biggest hole. Okay, find the biggest hole. So, you may get confused with first and worst. First may start searching from the first. Whenever you get the first biggest, store it there. But worst fit says start searching from first till the last. Now do comparison amongst all the big, which one is the biggest? Put in the biggest. Madan, okay. So anyone who wants me to solve one more? Anyone without hesitation who wants me to solve one more? Okay, so none. Please try now for 417, 112 and 426 and give me the answers. If you're done, write in the chat box done. Okay, Madan is done. Madan, let's wait for 1 or 2 more friends to finish. Anyone who's not clear and would like me to repeat with one more example? Okay, Subhash is done. Okay. Madan and Shubha is done. Okay, let's wait for one more at least. Bhumik is done. Ram is done. Okay, so Ram ने तो दे ही दिया था correct answer. Rashmi, okay, I think Rashmi ने भी पहले दे दिया था answer ना. Diman, let's let them meeting. Okay, there is one girl whose name is Anita. Anita, are you done?
Yes, ma'am.
Okay, so Anita is the one who will give me the answer for 470. So Anita, process P2 with size 417 will be allocated which one of the memory? Anita, 417 sized process which will be given which memory allocation? Not completely done, ma'am.
It's 500, ma'am.
Very good. Okay. So now 417, very good, Anita, will be given 500K memory allocation. Okay. So how much is left? 17 means 80. 80 में 3 गया. नहीं, 18 में 7 गया. 3, so I think 73. If I'm wrong, please correct me. So 73 size is left. Okay. So now Ram, please tell me 112 will be put in this which memory partition? Very good, very good. 388. What is the memory hole that's left? What's the size of the hole? 276. I think it's correct. If it's wrong, please correct me. So now, who else had finished? Rashmi. Rashmi, now give me 426 will be put in which memory allocation?
Ma'am, it will wait.
I'm sorry, Rashmi, I couldn't hear you. Rashmi, I couldn't hear you. Could you please repeat once? Okay, it must wait. Very good. Okay. So according to worst fit, the 426 sized memory will have to wait. Will have to wait either for process P2 or for process P1 to complete its task. Okay. So now for this particular problem, now what do you think? Which algorithm will operating system choose? For this particular problem, which one turned out to be the best one? Can you tell me first fit, best fit or worst fit?
Ma'am, best fit.
Very good. Okay. So for this problem, best fit turned out to be the best one because it accommodated all the process requests. So this is it for the various memory allocation algorithms. So with the help of searching, comparison and sorting algorithm, you'll have to implement it in the lab. You'll get 1 week time to implement all these 3 programs. Okay. So this is it for today's class. So if you have any doubt, you can ask. If there is anyone जिसको कुछ भी समझ में नहीं आया, you can write it in the chat box while I'm checking if your attendance is stored or not. आपका attendance हुआ है या नहीं, जब तक मैं check कर रही हूँ. Write in the chat box each one of you if you have understood it or not, if it's clear or not, if you want me to repeat, and if there is one single student who thinks I should repeat all of these 3 algorithms, I will. Okay. तो जब तक अटेंडेंस चेक करिए, प्लीज छोड़ना नहीं, फिर वहां से हट जाएगा. तो आप लोग प्लीज चैट बॉक्स में लिखो. एंड प्रकाश, प्रकाश प्लीज इन्फॉर्म अंबर दैट ही विल आल्सो हैव टू इम्प्लीमेंट द प्रोग्राम्स. आई थिंक ही हैज लैब practical backlog in practical. Okay. Okay, so your attendance is recorded. If you have no doubts, you may leave the classroom. Those of you who have doubt, you may ask me your queries. If you have none, you may leave the classroom. Prakash ma'am, when we submit assignment, Prakash, lab 1 or theory 1? Theory. Prakash, today is the last date. In Google Classroom, theory to submit theory's assignment, one folder has been created. You can submit it there. Today is the last date. राम, आई एम सॉरी, नो, क्योंकि लास्ट वीक थर्सडे था, तो आपके रिक्वेस्ट पे ही, आप लोगों के ही रिक्वेस्ट पे कि कंप्लीट नहीं हुआ है, मैंने 1 वीक एक्स्ट्रा दिया था. तो आप ऑब्वियसली आई एम सॉरी, या प्लीज रिपीट. विच वन वाला? वॉइस वाला? हाँ, प्रोग्राम ना, ऑपरेटिंग सिस्टम का प्रोग्राम ना. हाँ, किस दोनों? एक तो थ्योरी का है, लैब तो अलग है ना. आपका लैब अलग है, आपका थ्योरी अलग है, क्योंकि आपका तो 2 सब्जेक्ट है जो मैं ले रही हूँ. One is your OS theory, one is your OS lab. These are the 2 subjects I'm teaching. Okay, so for those 2, you are supposed to submit it on last Thursday, but your fellow friends asked for some more time, so 1 week more was given to you guys. Okay, that is today. एंड फ्रॉम द बिगिनिंग जब भी मैं एम देती थी, आई यूज्ड टू टेल यू करके रखो, फिर एक ही बार बोलूंगी तो मुश्किल होगा. सो आई एम सॉरी, आई कैन नॉट गिव यू मोर टाइम. सो यू विल हैव टू, आज का तो आपको और टाइम मिलेगा, 1 हफ्ता, लेकिन आज से पहले का जितना भी लैब और थ्योरी असाइनमेंट था, यू विल हैव टू सबमिट इट टुडे. It's not that you cannot submit tomorrow. Yes, then it will be marked late and accordingly you will be evaluated. Any further queries?
Ma'am.
Yeah.
Ma'am, आज को assignment छ नि?
हजुर.
Ma'am, त्यो last assignment चाहिँ attach गर्नुपर्छ?
आजको यो फर्स्ट फिट, बेस्ट फिट, वर्स्ट फिट?
Yes, ma'am.
No, आजको पर्दैन. आजको त you will get 1 week extra time, no? आजको for 3 programs, not 1 week, you will get 10 days time. आज 24 है, तो आपको 4 तारीख तक करना पड़ेगा, क्योंकि 3 प्रोग्राम है.
अनि मैम यो प्रोग्राम को मैम डिफरेंट पीडीएफ बनाएर पेस्ट गर्नु मैम?
डिफरेंट पीडीएफ बनाउँदा पनि हुन्छ. अहिले गर्दै गर्नु, फेरि म एक दिन जब भन्छु त्यतिखेर फेरि कलेक्ट गर्नुपर्छ. बट बाई द एन्ड अफ द सेमेस्टर फेरि सबै पीडीएफ को एउटा फाइनल पीडीएफ बनाएर, त्यो चाहिँ तिमीहरूको ल्याब फाइल, ई ल्याब फाइल भन्दा हुन्छ, त्यो हुन्छ. सो एभ्री टाइम बिचमा जब जब सबमिसन माग्छु, अलग अलग पीडीएफ बनाउनुपर्छ.
ओके मैम, थ्यांक यू मैम.
मोस्ट वेलकम. Class, if you have no queries, please leave the classroom.